Hi, welcome to my tutorial on solving real-world problems inside ArcGIS. Let's see what we are learning today. First of all, we will see an example scenario where we are given an example question. We will try to understand the question, how to approach the problem, then how to apply ArcGIS and Excel skills to find out the result. So, without further ado, let's get started. This is the problem statement. I am not going to bore you by reading the whole thing now. If you need, please pause the video and read it. Now, after reading it, you may feel overwhelmed by this number of questions. But to make the situation easier, let's go with small steps. The data given to us are two polygons in BTM projection. I have divided the questions into three parts. In part 1, we are asked to calculate percentage of only served area, overserved area and unserved area within RCC area, and in the next question with reference to total RCC area, and in the last question with reference to ward area. We can see that all three questions require the area of polygons that are served, unserved, and overserved. They have to be also divided with the word number. So, from the question, we can say that we need a table having area column, word number column, and type of service column. Summarized steps for solving the problem is given here. Anyway, let's jump into ArcMap. Let's import the provided data in our project. As stated in the question, we have to do calculations with only primary schools. So using attribute table, I am selecting the rows related to primary schools and keeping it as a separate layer. Now we have to apply buffer of now we have to apply a buffer of 500 meter to selected points. As a result, we have a layer with some overlapping polygons. The overlapped areas are overserved areas. Not overlapped areas are just served areas and the other areas are unserved. To get overserved areas, we can use the intersect tool. When used with only one input, it intersects with itself and outputs the overlapped areas. To get the only served areas, we can dissolve the buffer layer. But this layer includes the overserved areas. So we have to use the erase tool to remove the overserved areas from the served areas. Then we will get only served areas. The unserved areas are similarly got by erasing the served area including the overserved area from resolved word boundary layer. Finally, we have three important layers: the unserved layer, only served layer, and overserved layer. Now we have to use identity on the original word boundary layer just like we did in previous tutorials to get all things in one layer. But doing identity three times is cumbersome. So let's merge the three layers together and then apply identity on the RCC word boundary layer. Before merging, for identification purpose, I am adding a field where I am storing just a simple hint about which polygon represents what. Now merging three layers, we got one layer and let's apply identity to the RCC word boundary layer. After that, we pretty much got all the things that we need. It is always good to calculate the areas at last. So I'm going to do that. Now let's copy all the data to Excel and make a pivot table. For our first question, we need percentage of area of service, coverage of primary schools within RCC boundary. For that, I am adding area in the value field and what column in rows field. The value should be shown as percentage of column total. Now answer to the question number A is ready. Then I am just duplicating the sheet to answer next question. It was the same thing except it was divided with the words with reference to the whole area. So it will be shown as a percentage of grand total. Now the question B is solved. Duplicating again and changing the area value field setting as percentage of row total will result in solving the question number C. Now let's see the part 2 of the question. Here, if you notice carefully, the question pattern is same, except now it is related with the population. We will use density and area to calculate the population of a polygon. So let's solve question number D, E and F. I am adding a new column in the table. Population will be the area multiplied by the population density. Now, using the exact same method, we can solve three questions. The only difference is we will use the calculated population instead of the area in the value field. Let's solve the last question now. It was about calculating percentage of population within overserved area based on the availability of services like double served, triple served, and etc. For that, we need all previous data and in a new data or column which indicates how many times a area is served. As I don't know any specific tool for that, I had to do some tinkering with the currently known tools, searching Google for solution or related concepts. Then finally found a solution that is somewhat working. If we union the layer and special join the union result with the original layer, the column is found. Let's solve the question now. For that, I am creating a new data frame, dragging the buffer layer here. To solve the question, we have to at first union the layer and then use the special join tool. Then we will get a table with relevant columns. Let's do that. In special join tool, I am selecting the union layer as input and original buffer layer as the join field. Now we have a field called join count. We can think of it as a amount of service in particular area. Now let's calculate the area again to be safe. Then copy all data to Excel and calculate the population using density column and area column. Then make a pivot table. As stated in the question, the population will be in the value field, join count will be in columns field, and word ID will be in the rows field. Then the area will be shown as percentage of grand total, and finally it is the answer. The calculations or problem that we did today is made possible because of GIS technology. We did some spatial analysis or modification of data and found the necessary table, then used Excel to get the answer. I hope today you learned something new. See you in the next tutorial.